So in today's video, we are going to talk about delta tables in Microsoft Fabric. We'll be talking about how we are going to create the delta tables in Spark within Microsoft Fabric, and then we will also be doing one practical lab. So let's get started. So the tables in Microsoft Fabric Lakehouse are based on Delta Lake table format, commonly used in Apache Spark. What is, first of all, Apache Spark? So it is an open source in-memory compute engine. It is used for the processing of the big data files. And then Delta Lake is a storage layer for Spark. So whatever processing of the big tables that we are going to do using Apache Spark, Delta table will be used as the storage layer. We are going to store all those tables into Delta Lake, right? So how the Delta Lake is useful in our case for big data workload is that it gives the relational database capabilities for batch and streaming data, right? So if we talk about Delta Lake, see, Delta Lake is a storage layer built on top of a data lake. So Delta Lake and data lake are two different formats, right? So what is a data lake? So in data lake, if we are going to keep any table, any files, so we can store any format of file in data lake. So it can be in Parquet format, CSV, Avro. So any type of file format we can save in data lake. But you cannot query those files normally the way we used to query the relational databases, right? So in that sense, Delta Lake actually comes to our rescue. In Delta Lake, whenever we are storing the tables in Delta Lake, it gives us this capability of query those tables in the same way the way we used to query the relational tables, right? So by using Delta Lake, you can implement a lakehouse architecture to support SQL based data manipulation semantics in Spark with support for transaction and schema enforcement. Let's move on to the next unit. So understand Delta Lake. So Delta Lake is an open source storage layer that adds relational database semantics to Spark based data lake processing. Tables in Microsoft Fabric Lakehouses are delta tables, which is signified by triangular icon on the tables in the Lakehouse user interface. So delta tables are schema abstraction over the data files that are stored in delta format. For each table, the Lakehouse stores a folder containing Parquet data files and a delta log folder in which transaction details are logged in JSON file format. So in this Parquet file, all the actual data which is there in the table contains in this Parquet file format, and then whatever changes or whatever operations that we are going to do on the table, that will be logged in this delta log folder in JSON format. So in a sense, if we are doing any semantic changes or any metadata changes, right, or any data operations, everything will be stored inside this delta log folder in JSON format. So this gives us many capabilities, such as it gives us data versioning and time travel capability. Since we have all the versions available in that delta log, so we can do the time travel, meaning we can go to the any past version of the table which if we want to restore. Similarly, it also gives us CRUD operation capability, right? So all the create, read, update and delete operations can be done on this delta tables. Similarly, we have ACID transaction capability as well. So this ACID transactions is the feature of relational databases, but in delta tables also we have support for ACID transactions. Similarly, the support for batch and streaming data is also there on delta tables. So while most of the relational databases including tables that store static data, Spark includes native support for streaming data through the Spark structured streaming API, and that we will be doing in the practical lab. So the underlying data format for the data delta tables is Parquet format. So Parquet format is the most efficient way of storing the tables. See how we can create delta table. So when we create a table in Microsoft Fabric Lakehouse, a delta table is defined in the meta store for the Lakehouse, and the data for that table is stored in the underlying Parquet files for that table. Okay, so the schema of that table will be there in the meta store, and the data of that table will also be there, but it will be in the Parquet file format. Okay, so one of the easiest way to create a delta table in Spark is to save a data frame in delta format. So uh, just think that okay, we have loaded the file, loaded the data in the file in uh, in Microsoft Fabric inside the lakehouse, and then while creating a delta table, we will first load that data which is there in that file in a data frame, and then we can create a table using this function save as table, right? And we have to give the format as delta. So with this syntax we can create a delta table inside the lakehouse. The code specifies that the table should be saved in delta format with a specified table name. So this will be the table name. Okay, and the data for the table is saved in Parquet file format in the tables storage area in the lakehouse. And the other thing would be the delta log folder. So a delta log folder will also be created there, and it will contain all the transaction logs of the table. Okay, so next is managed versus external table. So we have already discussed about it in our earlier video, but let's recap it. So the data frame in our last example that we have just discussed, we have saved the table as a managed table over here. It means that the table definition is in the meta store, and the underlying data of this file is also managed by the same Spark runtime for the Fabric Lakehouse. So if we delete this table, the underlying uh, uh, files from the table storage location will also be deleted. But we can also create the tables as an external tables in which the relational table definition in the meta store is mapped to the alternate file storage location, right? So the metadata of that table will be there in the meta store, but the actual data will be somewhere residing somewhere else, and then that table, the metadata is mapped to uh, uh, this file which is in the external storage location, and that we can. So while creating that external table, we are, if you can see in this example, we are still using the same method save as tables, and then we are explicitly defining the path of the file where the actual file is residing, right? So and then we are also giving the file format which is delta format, right? So in this example the table definition is created in the meta store, okay, but the Parquet data files and the JSON log files for the tables are stored in the files storage location, right? We will see all this thing in the practical lab that we will be doing in the upcoming session. So and you can also specify a fully qualified path for a storage location in this way as well, right? So here we are just giving the fully qualified path name of the external table, right? And if we delete an external table from the lake house, only the metadata will be deleted, but the actual data will still be there. So creating table metadata. So while it's common to create a table from existing data in a data frame, just the way we did in the above two examples, so there are other scenarios also where we can create a table definition in the meta store but populate the data in other ways. So there are multiple ways that we can accomplish this goal. So one way is use Delta Table Builder API. Delta Table Builder API, what we can do is we can write a Spark code to create a table based on our requirement, just like we are doing here, right? So what we are doing, we are just creating a Delta table with all the column names over here and giving the data type for those columns, and later uh, we can populate the data for this table. So Delta Table Builder API is one of the way to do that, and then we can use Spark SQL, right, to create a Delta table. So again here we are creating a table, a Delta table, the table name with all the column names with and their data types. right? So we are creating the delta table here. So in the previous examples, we are creating the meta manage table, right? We can also create an external table by specifying a location parameter, just like here we are doing. We are creating an external table and we are specifying the location. Okay, so when creating an external table, the schema of the table is determined by the Parquet files containing the data in the specified location. So this approach can be useful when we want to create a table definition that references data that has already been saved in the delta format, or based on a folder where we expect to ingest data in the delta format. So in above scenarios, what we have seen is how we can save a data frame as a delta table, where we were creating the table schema definition in the meta store and the data file in the delta format. And the second scenario, we saw how to create a table definition which creates the table schema in the meta store without saving any data files there. A third possibility is to save the data in delta format without creating a table definition in the meta store. So this third approach can be useful when we want to persist the result of the data transformations performed in Spark in a file format over which we can overlay the table definition maybe later point of time, right? Or process directly using the Delta Lake API. So here we are doing this. For example, the following PySpark code saves a data frame to a new folder location in Delta format. So here we are writing the table in Delta format and then we are saving it in a specific location. So after saving the Delta file, the path location that we specify includes Parquet files containing the data and a Delta log folder containing the transaction logs of the data. So any modification made to the data through the Delta Lake API or in an external table that is subsequently created on the folder will be recorded in the transaction logs. So we can replace the contents of an existing folder with the data in the data frame by using overwrite mode. So we can specify the mode, either it can be overwrite or append, right? So that we can do. And here we are using append. Yeah. So we will move to the next unit where we will see how to work with delta tables in Spark. So you can work with delta tables to retrieve and modify the data in multiple ways. So one way is to use Spark SQL, right? And this is the most common way because most of the people are familiar with writing SQL statements. So for that, what they usually do is, so if they are in the Python notebook, so there they can write the SQL statement using spark.sql library, right? They can use it and then inside it in double quotes they can write the SQL statements. We can also write with magic command, so percentage SQL. With this magic command again we can use SQL statements. Okay, so these are the two ways that we can work with delta tables using Spark library. Another way to work with the delta file is using delta API. So in case if you don't want to work with the catalog tables and want to work directly with the delta files, what we can do is we can create an instance of delta table from a folder location, right? So this is where we are creating the instance of the delta table, right? Here we are specifying the path of the file where our delta file is located, and then we are creating an instance of that file, and then we can work on that file by giving any operation that we would like to do. So here what we are doing is we are just updating the table by reducing the price of the accessory by 10%, right? So here we are not working with the catalog table, but we are directly working on the delta file. So this is another way of working with the delta files. So another use case is to work with the delta table with table versioning using time travel. So whenever we are doing the modifications on the delta table, everything is logged in the transaction logs for the table, and we can use those logged transactions to view the history of changes made to the table and retrieve the older versions of the table, right? So we can see the changes by using the command describe. We can use describe history and the table name. So this will give us all the changes that we have done in the delta table. In this example, what we can see is there are different versions in this column. So we have 0, 1 and 2. These are the versions. This is the timestamp, and then what operations was performed on that table. Firstly, it was create table, and then there was some write operation which was done, and then there was an update. So all these changes, whatever was done on that delta table, has been logged in this transaction log. And to see the history of the external table, we can specify the folder location instead of the table name, right? So here we are specifying the folder location, and then we can retrieve the data for a specific version of the data by reading the delta file location into the data frame. So in this case, we can use this option version as of, right? So here in this example, we are reading this file from this path, and then we are giving the option version as of 0. So it will read the version as of 0. We can also give timestamp as of as the option, right? So here we can give the date as the option. These are the ways with which we can work on the delta table. Next unit, let's move on to working with streaming data. So up till now, we were working on delta tables which were static, right? But here in this example, we will be working with the streaming data. Now, many data analytics scenarios involve streaming data that must be processed in near real time. For example, we might need to capture readings emitted by IoT devices and store them in a table as they occur. For example, for smart home solutions where we have to capture the temperature of the room, the humidity of the room at every second. So the real time data will be captured there. Also, there are some other use cases where the security cameras are capturing the live video feed, and then that can generate some alerts. So all these examples are of near real time data. So for this, we will be using Spark Structured Streaming API. So a typical stream processing solution involves constantly reading a stream of data from a source and optionally processing it to select specific fields or aggregate the data or otherwise manipulate the data and writing the result to a sink. So Spark includes native support for streaming data through Spark Structured Streaming, which is an API, and it is based on boundless data frame in which streaming data is captured for processing. So what boundless data frame means that there is no limit on the number of rows that it can write the table to. The number of rows can grow to any limit. A Spark structured streaming data frame can read data from many different kind of streaming sources, and it includes network ports, real-time message broking services such as Azure Event Hub or Kafka, or a file system location. We can use a delta table as a source or a sink for Spark structured streaming. For example, we could capture a stream of real-time data from an IoT device and write the stream directly to a delta table as a sink, enabling us to query the table to see the latest streamed data. Or we could read a delta as a streaming source, enabling us to constantly report new data as it is added to the table. In this below example, we are using PySpark example, and in this, a delta table is used to store details of internet sales order. So if we can see here, this is the data frame, and then here we are using read stream to read the data from this location, file delta internet orders, right? And then we can perform any operation on top of this data frame. So in this example, we are simply using this show operation, right? But apart from that, we can use any of the operation that we would like to do. We can also aggregate this data, and then send it to the downstream application based on the requirement. Okay, so when using a delta table as a streaming source, only append operation can be included in the stream. Data modifications will cause an error unless you specify this ignore changes or ignore deletes option. So we have to specify this because this is an streaming data and we have to use append option only. So the next topic is using a delta table as a streaming sink. So in the following PySpark example, a stream of data is read from a JSON file in a folder. So the JSON data in each file contains the status of an IoT device in the format device and the status. The new data is added to the stream whenever a file is added to the folder. The input stream is a boundless data frame, meaning there is no limit and it keeps on adding the rows. So then it is written in the delta format to a folder location for a delta table, right? So in the code, as you can see, the input path has been given. So in this input path, the new data is added as a stream, and then here is the schema defined for this data. So we have two rows for this table, device and the status, and then what we are doing is we are reading this stream. We have also defined the schema, right? And then we have given the input path also from where this data frame is reading. Later we can use this data frame to write the data in a particular location. So we are writing this stream to this delta table. The path we have defined here, and also we are giving as a checkpoint here, and we are using checkpoint location option. This option helps us to recover from any failure at any point of time. So the checkpoint location option is used to write a checkpoint file that tracks the state of the stream processing. This file enables us to recover from failure at any point of time. After the streaming process has started, we can query the Delta Lake table to which the streaming output is being written to see the latest data. In the below example, this was the location where the streaming data was written. So here we are creating a table and then we are checking the data from this table. To stop the streaming of the data being written to the Delta Lake table, we can use the stop method of the streaming query, just like this. And that wraps up our session on working with Delta tables in Microsoft Fabric. I hope you found this tutorial helpful and informative. In our next video, we will dive into practical lab part where we will get hands-on with everything we have covered today. Make sure to like, subscribe and hit the bell icon so you don't miss out on that or any future videos. Thanks for watching Power Analytics and see you next time.